So we will now talk about recurring problems in distributed systems. So what kind of problems do we have? We'll start this with a simple teaser. So this is called the two general problem. The problem here is about how two actors try to achieve mutual knowledge under certain assumptions. What are these assumptions? The assumption that they can only communicate through sending and receiving messages, and messages can be lost with a definite probability, and mutual knowledge should be achieved during a finite amount of time. So just if we look to the problem, we have two armies on the top of two opposite hills, and they want to take a town in a valley in between the two hills. The problem here is that they need to coordinate an attack to happen in a specific time. If they attack in the same time, they win, otherwise they might lose. So say it again, the two generals must agree on the time of the attack. They'll win only if they attack simultaneously, and they communicate only through messengers, and the messengers could be killed. So let us try to solve this problem where we have these two generals. So General 1 send the time of the attack to General 2. But for General 1 to be sure that General 2 received the message, he has to do something. And what is it? He has to let General 2 acknowledge the receipt of this message. So General 2 should send a receipt of that message so that General 1 knows that they both agree. But now we have a new problem: how to ensure for General 2 that General 1 received the acknowledgement. How can we do that? Well, the solution is to let General 1 acknowledge the receipt of the act. And we can continue on this way, and in fact this problem is impossible to solve. In general, we have a distributed system where two nodes need to agree on a mutual value or mutual knowledge, and they communicate by messages using unreliable channel. This is an example of one form of agreement. So agreement really is an important problem in this distributed system, and we call it a core problem. So what is agreement? So one specific problem in distributed system is called consensus. Let us say we want to agree on a number. We have a set of processes communicating through a network, and they want to agree on a number. So what is the consensus problem? The consensus problem is as follows: all nodes propose a value. Some nodes might crash and stop responding, and the problem must ensure that all non-faulty nodes that survive, because some might crash, will eventually decide, and every node decides on the same value, and the value decided is one of the proposed values. So this is a typical problem called consensus. Consensus, in fact, is important in many applications of distributed systems. So take, for example, the problem of distributed databases. A distributed database is a database where data is partitioned between different nodes, and we want all updates of a transaction to be atomic. That means it's all done on all the nodes or on none. So we have concurrent changes to the database, and the nodes have to agree on changes. So in this we use some kind of consensus, some kind of agreement called atomic commit, where it has nodes can only propose one of two values, commit and abort. If they agree, the changes will be visible to all consequent operations in the database, that's the commit. And if one fails or aborts, all others should abort, so they all should produce a decision abort, as if the changes were never made. No one sees the changes. Another core problem is atomic broadcast. So here is a specification of atomic broadcast. All nodes broadcast a message. If the sender is correct, it means the sender did not fail. All correct nodes will deliver the message, and all correct nodes deliver the same messages, and messages are delivered in the same order. Again, here you can see delivered in the same order. That's also an agreement problem. Atomic broadcast is an important core problem because once you have atomic broadcast service, you can implement replicated services, for example, multiple servers that all of them execute the same sequence of command. Starting from the same state, executing the same series of deterministic command will yield the same output. And if some of these nodes fail, it doesn't matter because the others have exactly the same state and they can continue providing the service. And of course, to do this, you can see it's easy to use atomic broadcast service for that, because atomic broadcast service will broadcast all commands to all nodes in the same order. And that will provide, of course, fault tolerance. So these are two problems. Let us now look at if they are related or not. In fact, atomic broadcast and consensus are related problem, in that sense that if you have an implementation of atomic broadcast, you can use it to solve consensus problem, which means to implement a consensus service. You can do that. And here is a way to do it. Every node broadcasts its proposal, and because all proposal will arrive to all nodes in the same order, every node will decide on the first received proposal, and that's because, as I said, the messages are delivered on the same order. So the issue is, given consensus, can we also implement atomic broadcast? The answer is yes, and you will see this in the course. And therefore we can say that a consensus abstraction is equivalent to an atomic broadcast abstraction. Given atomic broadcast, you can implement consensus, and given consensus, you can implement broadcast. In conclusion, as you can see, agreement is one of the core problems in distributed system. Whether we can solve it and how will depend on which distributed system model we assume. And that will be the talk of the next unit. To summarize, we have illustrated the importance of distributed systems from a societal and technical point of view. And the study of distributed systems include both partial failure and concurrency. Both together are challenging tasks. We have shown that there are some core problems or core services such that consensus or agreement are necessary to implement these reliable services. We have seen that some problems are equivalent. Given one, we can implement the other. And in fact, we will see that consensus is not solvable in some models. So the next unit is looking to the models and see what models we have in a distributed system. Thank you.